This PowerPoint is about quadratic equations. Before, we have already learned about the standard form of quadratic equation. Usually is written in this form: y equals to ax squared plus bx plus c. And now we are going to learn a new form called the vertex form. We would use a method called method of completing squares to change the standard form into the vertex form. And later on we will see how this format is useful for finding the maximum or minimum values for certain questions. For example, when we look at the quadratic equation in its vertex form, we can already know the x coordinates and y coordinates of the vertex is actually hk, and also the sign of A gives information about the graph, whether it's opening downward or opening upward. For example, in this case, when A is greater than 0, it means the graph actually opens upward like this. And when x is at the vertex point, that means x equals to h. Actually, the function y gets its minimum value at k. And the vertex point is hk, and it is also the minimum point of the graph. And when, in this case, case 2, when A is smaller than 0, actually it means the graph opens downward like this. And when x equals to h, that means here is at the vertex point, y is actually the maximum value, and that means k is the maximum value for y when A is a negative number and x equals to h. So the maximum point is hk. So let's see an example. From here we can see that y equals to x minus 3 all squared minus 6. So we can see from here that actually A equals to 1 is a positive number, so it means that the graph opens upward. And we can directly read from this form is because it's already in vertex form. The vertex is actually 3 and minus 6 and is the minimum point. Example 2. Here we can see that A is minus 2, so it means that the graph opens downward. And also we can imagine that actually this bracket is x minus negative 1. So the h is actually minus 1 and the k is plus 5. So actually the maximum points now is minus 1 and 5. So now it comes the method of completing square. Actually it means that for the first half of the equation, whatever we see in the standard form, we can add a term so-called a divided by 2 all square to make it into a perfect square like this. So what does this actually mean? Actually mean, for example, when y equals to x squared plus 2x minus 4, we want to make it into something that we can group it into a perfect square in the final step. So at the beginning, we can just omit looking at the minus 4 term and just focus on the first half of the equation, and the middle coefficient, whatever it is, we add another term by writing this coefficient divided by 2 all square. So this is already something that we can group into the format called x squared plus 2xy plus y squared. So now because we need to balance also the value, so after adding this term, which is an extra, we minus exactly the same magnitude, and then keep another term as before. So now this is called method of completing square. And by looking at the first half here, we see that it can be grouped into x squared plus 2xy plus x squared plus 2x plus 1. And then here is minus 1 minus 4. So altogether, after the perfect square, we have minus 5. And then, as we said before, when a is greater than 0, actually this is a graph opening upward, and the function y would have its minimum value, so now it's minus 5, and it means when x equals to minus 1, y is minus 5, and the vertex should be minus 1 minus 5, which is the minimum point. And example 2, here we have minus x squared plus 6x plus 1. Again, we can omit looking at the plus 1 term and just focus at the first half of the equation. But we need to take notice that there's one extra minus sign here, so we need to deal with it by taking it out as a factor, and then rearrange it into this form, x squared minus 6x inside the bracket. And in order to make it perfect square, again, we take out the second coefficient, minus 6, and write a term called minus 6 divided by 2 all square. And then again, balance the value by minusing the same magnitude. And altogether, we have this for the first half of the equation. Is actually, again, is x squared minus 6x plus 9 equals to x minus 3 all square. And the other terms can be grouped into one number. And as we said before, when a is smaller than 0, actually the graph opens downward. So the function y would have its maximum value, and now this number is 10. And again, it only gives the maximum value when x equals to 3. So before, this number is represented by h, and this is k. And now we can understand why. Because when x is 3, that means 3 minus 3 is 0, and obviously this is then the maximum value. This slide actually gives an example about what to do when the coefficient before x squared is not 1. So, like this, when the coefficient before x squared is 2, we would take out the 2 as a common factor for the first two terms, and then we arrange it, and then again add the same thing, the second coefficient divided by 2 all square, and minus the same magnitude, and then keep the other number. And after factorizing it, this is again a perfect square. We can factorize it into this format, and then these two numbers add up to 9. Again, this is a graph opening upward because a is 2 greater than 0. So the minimum value of the whole function y is 9 when x equals to 5. And the minimum point is actually 5, 9. And this is the vertex. And now we can see that what is the application of using completing square in solving math problem. Like this case, in a right-angled triangle, if the total length of the two sides forming the right angle is 16 cm in total, find the maximum area of the triangle. So the first step is that we need to figure out what this triangle looks like. So obviously we can set the parameter like one of the unknown length is x, and then the other side must be 16 minus x. And also we need to write down the quadratic equation of finding the area of this triangle. It should be 16 minus x times x and divided by 2. And the next step is that we need to rearrange the equation into the vertex form and also by completing square. So first we need to take out minus 1 over 2 and put x squared at the front and minus 16x. And then again we take out the second coefficient and add a term called minus 16 divided by 2 whole square. So it should be x squared, and then to balance it we minus another x squared, and altogether this one is the perfect square, which could be grouped into this way, and the next term is minus 64. After calculation we can see that actually the vertex form is finalized as this. So that means when x equals to 8, it gives the maximum value of 32 for area A, so we can conclude like this. From here we can see another example is that the cost of producing a notebook computer by a certain manufacturing company is $C, and C equals to this equation as given, where X is the number of notebook computers produced each day, so we are required to find the minimum cost. Again, it can be calculated by completing square. How to do it is from here, we can see that it's by taking out the vector 4 and then try to make this into a perfect square by taking out the second coefficient minus 6t and then add a term called minus 6t divided by 2 all square, and then again minus the same magnitude to balance the overall value, and then keep this number as is, and then finally this bracket can be factorized again into a perfect square like this. And from here we can already know by heart that this is a graph opening upward. It means this number should be a minimum value when x equals to 30. So we can conclude like this. C is actually at its minimum value when x equals to 30, and the production cost is minimum when 30 notebooks are produced per day.